Let's get a little bit deeper and talk about conditions and select statements in bash scripting. So conditions are statements we can use to evaluate whether something is true or false. So it gives us an ability to test conditions to figure out, how our script is going to move forward, right? So we can do different things based on different conditions. I will say that the syntax for conditions, really the syntax in general for bash scripting, is very different than a lot of other programming languages. So if you learn things like Java, C++, or C, or .NET, or whatever your programming classes have, this is going to feel a little bit different. It's going to feel a little bit antiquated in some ways. But remember that bash scripting was developed a long time ago. It was originally created as just a shorthand for creating simple scripts, and it's kind of grown from there. So, there's a little bit of history there. So it is going to seem a little bit antiquated, but there's a lot of cool stuff you can do with bash scripts. Conditions are always going to be placed either in square braces or in double parentheses, and it really depends on what type of condition it is, whether you're going to use one or the other. I will say kind of an easy way to remember is the square braces are generally used for string comparisons, whereas the double parenthesis is going to generally be used when you're working with integers, numbers, and things like that. So that's the primary difference. So we can compare strings using equal and not equal to. It's important to remember that equal is two equal sign. If you're comparing to see if two things are the same, it's going to be two equal sign. If you use a single equal sign, it'll either error or do something you didn't expect it to do. And then not equal, of course, is the exclamation point equal sign. So we can only compare strings, again, using the square braces. We cannot use those double parentheses. So that's kind of what I always remember is if I'm working with integers, I'm always going to use the parenthesis. If I'm using strings, I'm going to work with the square braces. If we're comparing integers, we can use greater than or equal to, not equal, less than, etc. Now, there's two annotations you can use to represent greater than and equal than and all that. You can see them in the slide deck here. I'd say the easier one to remember is the standard ones that are to the right, The standard greater than, equal, and so forth. They're pretty similar to other programming languages. The -GT, -GE, -EQ, those are a little bit hard to remember because most people aren't familiar with those. They're really unique to bash scripting, but they'll almost always work. So especially on legacy systems, sometimes you don't have the option to use the other annotations. So again, that only works if we're comparing integers or numbers, digits and so forth. So here are some examples. You can see in the first example, you use the square braces because we're comparing a string variable, so a variable that we know contains a string, to a literal, So Frank, as written there, would be a literal. It's a string. It doesn't hurt to use double quotes. You can see in that fourth example, the double quotes were added. That's important because without the quotes, the interpreter doesn't know how to handle the spaces, So if there's spaces, you really have to have quotes, but it never hurts to have those quotes, and it's definitely best practice. And there are some interesting errors that you can see here. It's showing you some error explanations on the right, even though some of these syntaxes look correct. They may not work, So for example, in the second one, there's no spaces after and before those square braces, so it'll fail, So little things like that are what you have to be aware of when you're using bash scripting, which can be kind of annoying. So when you're using the square braces, each part of the condition has to be separated by at least one blank space. So it's important to remember those spaces we just talked about in the previous slide. So if we expect, for example, the variable $x to have a space, you have to place it in double quotes around that x, if you expect it to have spaces, because again, the interpreter will look at spaces and think it needs to do something with those spaces and thinks it's multiple arguments or things like that. So important to be aware of. When you're using the parentheses, you can omit the $signs in front of variable names, especially when you're using greater than and less than. So it's not necessary to have the $sign. It'll still work though. You can have the $signs if you like. It'll work either way. Compound conditions are when we conjoin using and or, So this is where we're going to have Boolean logic. So bash scripting of conditions support Boolean logic, and the annotation is double ampersand for and 2 pipes for an or. Very similar to what we talked about in awk, right? So in awk, we were able to use some of these annotations. So again, very similar, and there's some examples in your textbook that are in that table below on this slide. So there is a test instruction in Linux. Basically, this lets you, if you use the test command, it's going to check to see if whatever you're passing in the test is true or false. So all it's going to do is return a 0 for true or a 1 for false, and that's pretty much it, right? So this is good if you're just want to see if your statement's going to work, if it's going to produce the output that you expect it to. So you can use the test. If you're going to use Boolean logic, you can use -a for and dash or for or, obviously. So you don't use the double ampersand or the double pipe in this annotation with this command. So you can compare a file to an attribute, right? So this is if you want to test the condition of attributes on files. So for example, -e is, does the file exist, right? So you can have, basically check to see if the file, is even there. Is it a file? Is it a directory? Is it a block device, a character device, and so forth. So you can test various attributes about a file, even who the user or group is that owns the file. So you can also compare two files with older than and newer than, right? So -ot for older than, -nt for newer than, and -ef if they are the same file. All right, so for selection statements, there are 4 types. If then, so if a condition is true, execute the clause, otherwise skip the instruction, right? You can read these different ones. So you have if then else, and then a nested if then else, and then finally case statements. So those are the 4. So the most basic is if then. So if something is true, do X, if not, do Y, right? If then else is check if a condition is true, check if another condition is true, and then otherwise do something else, right? And you can have multiples of those. You're not limited to just the 3. And then finally, you can have nested if then else statements, where inside an if statement, you have additional if statements and if then else statements and control structures. And then finally, case, which is kind of a shorthand way to do this. You may be familiar with the switch operator in something like Java. So let's talk about these. So the if then syntax, basically you have an if. Every time you have an if, it has to be end with phi, right? It's just if backwards, right? In most programming languages, you use brackets or braces or parentheses or, something to contain the statements, right? But bash scripting doesn't have that. We already use the braces and brackets for testing conditions. There's other syntax for those. So instead, it uses this syntax where you have a backwards if. The only thing I would say is maybe it could be similar is Python, right? If you've taken or learned Python, there are no parentheses or brackets for if, then, and loops and things like that. That uses white space and indentation in its syntax. Bash doesn't care about white space and indentation, other than the white space around variables and things like that, which we talked about. So the only way to tell it when an if or a then begins or ends is with that backwards if. And it's the same thing for else if, right? If you have an else if, you end it, or elif, it's ELIF, you end it the same way. Case gets ended by spelling case backwards, right? So again, feels a little strange, right? This syntax, but it's been around for a long time, and you'll get used to it if you start using it. So here's an example. If the value of the variable $name is equal to Frank Zappa, which is the author of our textbook, then it's going to carry out those instructions, and then we end the if. So this is the most basic type of conditional. Here's a if then else, right? So here we're checking to see if the score is greater than 60, and then we pass, otherwise they fail, right? So that's a simple one. And then we have an if then else, right? Where if y is not equal to 0, then we do something, otherwise we say cannot divide by 0. We're trying to basically make sure we capture a 0 so we don't divide by it if somebody accidentally entered a 0. And then here we have a file comparison. I didn't show you an example of that a few slides ago, but this is what a file comparison might look like. So here I'm sorry, this is not a file comparison. We're reading in a file, right? So $file is equal to script1.sh. So that's another example of an if statement. Now here we see in this example, let's say we're trying to calculate grades, right? So we pass in a letter grade and we want to pass out what the grade is, or a number grade rather, and we want to get back out what the letter grade is based on this very simple grading system, which we should all be familiar with. The top one is logically correct, right? That's going to calculate the accurate grade, but it's very inefficient, as is the bottom one, right? So both of these will work, but they're not very efficient. There's probably a better way to do this. So here are two other ways to do it. The one on the top, we are using an else if here, right? So instead of doing a bunch of individual if statements, so it has to check the condition every single time, which is what makes it less efficient. Here we're checking conditions one time, and once it's true, then it shunts the rest of the script. So it's definitely a lot more efficient. The one on the top is logically incorrect. If you look at it, it's incorrect because that very first else if, let's say the student's grade is a 65, right? Is that greater than or equal to 80? Yes. Is it less than 90? Yes, right? So it would give them a grade of B even though it should be a D, right? So that's logically, even though it looks like it could be correct. So it's important to evaluate the logic in our scripts. The one on the bottom is the best solution, right? All we have to do is check to see if it's greater than 80, that's a B. If it's greater than 70, that's a C. If it's greater than 60, it's a D, and so forth, right? So that's probably the best solution and the most efficient. So here are two scripts to find the largest of three input values. So the first solution is pretty straightforward. We have an if statement that's, a separate if statement for each to test the condition. It'll work, but then the bottom one is a little bit more complicated, but it would scale better, right? It'd be easier to modify this program to work with additional variables. So that's a different example. And again, the one on the bottom is nested if then else, right? So we're kind of nesting in there. So here's a simple calculator script that we're going to input two numbers and then a symbol, and then it's going to calculate it for us, right? So the idea is you put in a number, then a symbol, and then it carries out the arithmetic for you. Again, really simple script. This really doesn't have any practical application, but just to show you some examples here, right? And of course, this one also tries to catch if you did not put in a valid arithmetic operator, right? So if you didn't put something valid. Now there is one problem with this. The textbook says it's a logical flaw, but it's actually a syntactical flaw. That if we use the asterisk or the splat for multiplication in bash scripting, splat already means globbing, right? So it's going to fail. It's going to do something you don't expect it to do. So you'd have to use a different symbol for multiplication, maybe lowercase letter m or something like that. So here is another example. Now we start to introduce the concept of case, right? So you learned about if then else, and then nested if then else on the previous slide. Case is just another mechanism, right? So case can oftentimes be more efficient than using a bunch of if statements, right? Because it's going to test the condition in a variable, and if it finds that condition, then it's going to carry out the instructions and then move on to the next one. You end each line with the double semicolon. If you end it with the semicolon and ampersand, it's going to not stop checking cases. That's unusual, not common that people do that, but basically if you use the double double semicolon, my apologies, it's going to stop testing conditions as soon as it finds a match. So as it's going through these different possible matches, once it finds a match, it's going to carry out those instructions, and then that's it. It's done. It's not going to test any additional conditions. If you use the ampersand, it is going to keep going. So it may execute more than one block of code if you're using the ampersand. And again, logically, it's not very common, but it's certainly an option. You may find a way to use that. So here is a different version of that script that does calculations. Here, instead of a bunch of if statements to check, whether, which operator the person used, Instead, here it's using a case. So in the case that $2 is a plus, it's going to just do addition. If it's a negative, it's going to do subtraction and so forth. Notice here that the M was used instead of the splat, because the splat would obviously cause an error if somebody tried to use that. So here is another example of using case. This one asks what's your favorite color, and so the previous one was an example using the integers with a symbol. We can certainly do string comparison, right? And this is what it looks like to do string comparison. And we're almost done here. This is a more complex script combining two different cases, right? So in the first part, the case is, does the person enter a yes or a no, right? And here we have multiple different possibilities that'll match on that case. So before that open parenthesis, that's the syntax for case, right? We have the open parentheses to list our cases. It can be, and remember what's inside those braces, that's really regular expressions, right? So what we're looking at there is a regular expression, which we learned about already. So it could either be just the letter Y, upper or lowercase, or it could be the word yes, and it doesn't care what case each of the letters is in the word yes. But if you typed YE, that probably wouldn't work, right? So it either has to be a Y or the word yes. The case won't matter. And again, this is using regular expressions to do that. So prior to System D, which we learned about already, prior to System D with the init process, we used a lot of scripts to start and stop programs, right? So what you would do is you would create a bash script file that was responsible for starting daemons, right? And you might have complex logic in there. It might test conditions and things like that. But you would write these little scripts to do that, and you would link to those through either the K or the S files. A K is a kill, S is to start, and then you would have a number, and that's the order that init would start or stop services based on the run level. So you would have a folder for a run level. Inside that run level folder, you'd have S and K scripts in numerical order. And really, that was just a link to a bash script somewhere that would start or stop whatever service it was in that order. Really primitive, but it worked, right? It was elegantly simple, primitive, but it definitely worked. So we used a lot of these bash scripts. A lot of bash scripting was, used by system administrators just to manage these things and to create their own startup scripts and things like that. You'll see in the lab, or you already saw in the lab, that System D works a lot different, and these scripts have become less important with System D for managing daemons and services. But there are a lot of other really good things we can use bash scripting for. So the concept of short circuiting is our last slide, by the way. The concept of short circuiting is when you're writing your conditions, you can bear in mind when you're writing them that you can test for conditions that are likely to be false to short circuit. In other words, in that first example, $x is greater than 0 or $y is equal to 0. It's going to evaluate the first one, and if the first one, because it's an OR statement, if the first one is true, it doesn't need to get to $y is equal to 0. It doesn't even need to check that. So if it's more common that it's greater than 0, $x, you can put that first, and then as soon as that's true, it just keeps going, right? Little tiny things like this can make things more efficient in scripting, and it's something a lot of times when you get really good at scripting, you start to think about these things, how to optimize your scripts or factor them so that they run much faster. But for the most part, with bash scripting should be shorter scripts that do that automate menial tasks and things like that. It's not always super important from a programming perspective to refactor these so that they're incredibly efficient, not like it would be if you were developing applications in C++ or something, but something to be aware of.